All right, everyone. Thanks for the intro. I'm Evan, protocol engineer at Jito, and going to be talking about node consensus networks built on Jito restaking. So let's get right into it. First going to talk about some background about what an NCN is and why you might want to build one. Then talk about how to build one with a very simple example for you guys. And then a bit about some real-world examples and the future of the protocol. So a framing I like to use is that, Solana is unique in that it uses the runtime for consensus, at least until Alpenglow is released. But we have like the vote program, stake program, we have vote transactions all landing on chain. Then expanding that concept a little bit, we have this third-party protocol called OR, which is really interesting in that it uses the Solana runtime for a proof-of-work protocol. Then extending that concept even further, a node consensus network, you can think of it as an arbitrary proof-of-stake protocol in the Solana runtime. And so Jito restaking is this Solana protocol connecting staked assets and node operators, which are the backbones of any proof-of-stake protocol, with these decentralized networks. And what we really want to do is we want new arbitrary proof-of-stake networks to be using Solana as their consensus layer, which then increases the network effect of valuable state on Solana, on the monolith chain. So what we provide is that this pool of capital that's looking for yield and an ecosystem of professional node operators that are looking to earn money running software. And what that does is that saves you the work of bootstrapping your network from the ground up, having to get all those things from scratch. So yeah, right now we're live. We have over $300 million in staked assets in TVL. We've got a number of vaults running and delegating this stake to over 20 high-quality node operators. And I think some of them are running around this conference right now. Why should you actually build an NCN? So this is for people who are potentially running a decentralized protocol that has some centralized component that would benefit from decentralization. Those benefits could look like maybe you want to increase trust from your users because you have some single authority and users want to see that be decentralized. Maybe it's actually like cheaper to run something as a decentralized protocol to let the market figure out how to run this infrastructure rather than run it all in-house. Or maybe you have some regulatory reason where your thing isn't actually considered a decentralized protocol until you split out the central authority and have a bunch of independent people doing some work. Maybe you also just have some protocol that has a network of untrusted participants and you want to give them some sort of economic stake, some skin in the game to make them more trustworthy. And then this last point is really important. You have to be able to incentivize participants to do work. I mean, this is Solana after all. We do care about revenue and think that's a good thing to do. And it's important to be able to have real yield, so to speak. However, the incentive models for NCNs can take a lot of different shapes, so I think that deserves its own talk. I'm going to go through the off-chain and on-chain components of how to build a very simple NCN. And the real-life kind of work that you have to do is just build the relationships with these vaults and operators who are going to be staking to your network and running your software. So yeah, the simple example that we came up with, kind of the most basic example of this, is a weather oracle for Solana Beach. So you can imagine every epoch, operators will submit a very simple weather status for Solana Beach, 0, 1, 2, sunny, cloudy, rainy. And imagine this being like part of a larger protocol where the protocol is collecting fees from Oracle consumers, or maybe it's some sort of prediction market where people are betting on what the weather will look like. And this is sort of how you get your revenue that will eventually be the yield for your stakers. And everything I'm about to show you, we do have a live code template for and a tutorial explaining through like actual code for how it works. This is the base diagram of all of the different components we have. We have on-chain components, off-chain components. What we've built here is pretty much the simplest design of every one of these components. But what we're looking to do is evolve this into kind of like a Chipotle experience where you can choose custom ingredients for every one of these different modules. And make it kind of plug and play, make it your own without too much extra configuration. But right now it's just a very vanilla, like plain bowl. So the operator client, What we're doing in this example, it's going to be a simple server with some access to a weather API. Every epoch is just fetching the weather for Solana Beach and putting that on chain to the NCN program. But you can imagine this being a lot more custom. This could be something like a depend challenger node or a depend like infrastructure itself. This could be something running a TEE and putting attestations on chain. This could be running custom ZK hardware. This could be a modified Solana node itself doing some other special thing. The snapshot step, this is where we actually set the voting weights for the operators in consensus. So we're creating a bunch of accounts to track state on-chain. We're pulling from some on-chain price feed to be able to weight the different assets that are staking to us, and then iterating through all of these vault and operator pairs to save the total stake weight for consensus. This ensures consistent voting weights throughout the whole process. And yeah, a couple of considerations here of how you might want to customize this. You might want to consider how many assets you actually want to support, because this means a more complicated Oracle setup, maybe more dependencies there. You want to consider how frequently your cycle needs to run, and the number of vaults and operators, because these are all things that you might want to optimize even harder if you have to run this step a lot. For the consensus step, this is probably the most interesting from like a crypto research point of view. In our case, we just do a very simple on-chain quorum where votes are coming in, we're tallying candidate weather statuses, and then once you hit a 2/3 stake weight agreement, then that's the fixed value, and you can serve that data to consumers, both off-chain and on-chain. So this could be like, now you can resolve that prediction market. Oracle consumers can use this value for whatever purpose they want. The customizable part here is what that verification mechanism actually looks like. So right now we just have a simple quorum. You could do something more complicated like a BLS signature aggregation. This is what Alpenglow is going to move to. Do something with ZK proof and then verifications afterwards. An optimistic proof with slashing afterwards. All different types. You also have to consider how to handle failures and like how bad a failure is for your specific use case, because what happens if the operators just don't submit any data? This last part, this is very dependent on that incentive or fee mechanism that you have, but a very simple way to think about it is that you have rewards accumulating in a reward router account, and then depending on the correct participation for the operators in your network, you're going to pay out the operators, the vaults that are staking to them, and potentially other parties like your protocol. Some other approaches to do this would be to upload a Merkle root on chain, and then you can do permissionless claims to all these participants, or completely run the reward distribution off chain, as long as your users are OK with that. A real-world example that we have live that was a main motivator for Jito to build restaking in the first place is the tip router. So since the inception of the Jito MEV client, Jito has been responsible for distributing MEV rewards to all validators and stakers on the network. This has been over $1 billion historically to millions of accounts. It involves a really costly off-chain calculation that has to be run super reliably and submit tons of transactions. We ended up with a single 32-byte Merkle root that gets posted on chain. And previously, this was all done by a centralized authority, but with the amount of value at stake here and just like, yeah, the core value to the Solana network, we wanted to decentralize this for redundancy and trust. So it's now an NCN where operators are all coming to consensus on what that Merkle root is, deciding distributions, and currently in the process of extending tip router to handle priority fee distributions as well. So a good example of how this, like a single NCN can evolve over time and handle multiple use cases, earning more fees, doing more things for the broader network, all with the same node operator set and the same staking to it. So this diagram looks pretty similar to the one I just showed you. The key differences here is that the operators, they're running a modified Solana node that creates a snapshot of all 1 million-ish stake accounts. It's calculating some Merkle root and putting that on chain. And then the step, like the consume step, is actually setting and distributing MEV tips to all the stakers and validators on the network. So the template for that weather status oracle is now live at these websites. Don't have a fancy QR code for you guys, sorry, but we have, everything that I just showed. You can go look at the code and see how it's actually running. And for the future, we're definitely going to be extending the different plug-and-play modules for consensus, reward distribution, how to actually get the prices for your vaults. Going to add other things like token 22 support and slashing to just flesh out the protocol. And so that's all I have. Thank you guys very much.